Okay, hi everyone. Today is lesson 2 for the Solidity Bootcamp, or challenge 2, may I say, because it's the third lesson. But yeah, let's continue for the Speedrun Ethereum challenges. We have the challenge 2 today. So what are we building? Today we are building a crypto vending machine. I don't know if we have one downstairs, but those machines that you get drinks from, you just put some coins in there and then you get something in return, right? But today we're doing that in crypto, digital crypto vending machine. So we're putting crypto inside the machine and we are allowing users to buy crypto from this machine. And also, this is another feature that current vending machines don't have, but we are also going to allow a user to sell the tokens back to the machine. This is a nice extra feature. So it's going to work like this one, okay? And what are some characteristics about today's workshop or this application or use case? Is that these machines, in real life, they are always available, right? So we're kind of doing that analogy with smart contracts, where a smart contract is a program in the blockchain that is always available and you can always interact with a smart contract, right? The other characteristic or I guess feature is that it's reliable. I put a little asterisk in there because this depends on if you are a good programmer, of course, and it does what it should do. And the other one is that no one can steal or cheat in this vending machine. And this also has a warning here, because you have to be sure that you program the contract well so that it doesn't have any vulnerabilities. So yeah, these are also characteristics of a smart contract. And what's our objective with doing this is we're going to learn about ERC20s. I believe yesterday we were talking about this with you in the use lesson. But this time we're going to implement it with Open Zeppelin as well as we did yesterday. We're going to talk about ownership of contracts as well and how to transfer this ownership so that other people or other users are the owners of these contracts. Ownership is very important for when you have very, I would say, risky functions or something that only managers or very special people should have access to. And we're also going to learn about the approve pattern. The approve pattern is a way to let other contracts or other users spend my tokens from my wallet, of course, from my balance. This is especially important for ERC20s, of course, but it can also be used on NFTs or other ERCs. This is an overview of what we're going to build. You have your token balance. In this case, we're going to work with a gold token, GLD. And we're going to have our vendor, which is going to be our vending machine, which is going to have itself a balance. And then we're going to be able to buy tokens from this machine. We can transfer tokens from our balance to another user. It's like exchanging tokens in real life or exchanging drinks. And we are going to be able to sell these tokens back to the machine. This is going to be like the hardest part of the workshop, but it's going to be fairly easy for today. And here we have a special approved tokens functionality that we're going to see. Okay, let's go. As always, be sure you have node 18 at least, but you can use also a node 20. Yarn and Git, of course. We're going to start by cloning out this repo. Let me finish these ones. Oh, the link for this is you just go to speedrunethereum.com and then let me go so that you can also do. you go to the challenge number 2, which is here. Token vendor, yes, this one. And we're gonna follow this guide. Let's start by cloning out the repo. Like I said, you should also be doing this in your, let me create some folders first. Okay. We're going to go inside the folder, and we're going to switch to the branch that has the files for this challenge. And then we install the dependencies with yarn install. Oops, yarn install. Does anybody have any questions with the thing that we're building today that I already showed? Okay. Now we have our dependencies installed, and we're going to start a local chain. I have to remember you that we're using Hardhat for this, but tomorrow we have a very special introduction to Foundry. So anything you learn here, you can use Hardhat or you can use Foundry, and we're going to see that tomorrow. Okay, so we have our chain started, and we are going to go ahead and deploy our contracts. We still haven't edited our contracts yet, of course, but we can already deploy our simple contract. Okay. And in a third terminal window, we're going to start our interface. I guess it's okay like that. Right. You should see this on your machine as well, and we have a token balance of 0. We haven't created our token yet, but we already have your token created. This is a contract that came with the installation of the repo, but we are gonna edit this now. We have 0.8 as well. Remember, you can get some funds from the faucet here with this button. Okay, let's go ahead and work on the token. Remember that this is a vending machine, and we're going to put crypto inside this. So to put this crypto inside the vending machine, we first need to create this crypto. And we create this with a smart contract, which is going to be called yourtoken.sol. We have this already here. You can open up an editor of your choice. I'm going to open up VS Code. Yes, I trust the authors. Is it doing that all the time? The black screen? Okay. Yeah. So weird. You can press Control P and go directly to the, your token. That's all. So straight up, the scaffold is, or the clone repo that we cloned just now already comes with this pattern that we saw yesterday, that we import the Open Zeppelin library, the ERC20 token, and we just use the is keyword to inherit all functionality from this ERC20 contract. Okay, you saw this yesterday with you, and we already have our basic constructor here, and for this constructor we are using the name of this cryptocurrency is going to be gold, and the symbol is going to be GLD. And here the challenge asks us to mint some tokens, or to create some tokens to our front-end address. Specifically, we're going to create 1,000 tokens, 1,000 gold tokens to our front-end address. So, okay, we're going to uncomment this. And this is using the mint function that is already available for us in the ERC20 Open Zeppelin smart contract. We're going to grab our front-end address from the scaffold interface, which is here. Copy address, and we're going to paste it here. And now, as you may remember, the tokens in Solidity or smart contracts usually use 18 decimal points, and for this is the reason that we are using 1,000, which is the number of tokens we want, and then 10 to the 18. So now if we redeploy this contract, we're going to have 1,000 gold tokens in our balance as the deployer of these contracts. We can try that now. Interface, chain, deploy. Remember that scaffold it is automatically compiling these contracts, redeploying them, and then updating the interface so that we can see the changes reflected right away here. So yeah, now it's showing me that I have already 1,000 gold tokens here as my balance. And we can debug this as well here. From the contract itself, we can call balance off, and we can see that we get the result of 1,000 tokens. It's pretty nice. Have you used the scaffold 8 before?
Yes.
Okay,
but
nice.
The interface looked different. Like I did it with the scaffold E website. Like I ran the command, and it was all white. It didn't have colors.
No, I guess they updated already. Yes.
Yeah.
So nice. It's very cool.
It's different.
Yeah. Okay, so let's go to checkpoint 2. For checkpoint 1, it's asking if we can check the balance off, which we already did. And we can transfer you can try this transfer function and try to transfer to your wallet or something and test if it works, but it should work.
So 1,000 for free, right?
No, it. no, it. This is just a custom token that we are creating right now, which name is gold, of course. Yeah. It will be cool, 1,000, to mint 1,000 it just from the air. Okay, we're gonna go to checkpoint 2, and it says we're gonna work on the buy tokens function. This is the one that we're gonna use to get the tokens from the vending machine. So this is our first time touching the vendor.sol contract. Let's go to our editor and then navigate to vendor.sol. As you can see, you already have some function comments here. We have an event here we haven't seen. We have your token instance, which is going to be an instance of this other contract, the token contract, that we're going to use here inside the vendor contract to call some methods. And here we have the constructor of the vendor contract. And this constructor is going to get the token address from the token that we created already and initialize this instance with that token address. So the first thing we're going to do is this buy tokens function, which should be fairly easy if it's just a function. Buy tokens. It's going to be public. And since we're going to use Ether to buy these tokens, we should do this function payable. And here you have the tip for this. And it says that the buy tokens function in the vendor.sol should use the message.value and the tokens per it to calculate the amount of tokens that you're going to transfer to the person who's buying this. So we got to add this variable tokens per it, which is going to act like our little conversion or exchange rate for our tokens. This is not that common, of course, in crypto. For conversions or exchange rates, you use like a pool of tokens with stable coins and tokens, but this is just for simplicity purposes, of course. Setting up, burning down is 100 tokens per ETH. So when we send like 100 as message.value, we're going to get 100 tokens. I'm sorry, if we send 1 as message.value, we're going to get 100 tokens in exchange from the vending machine. So, okay, we're going to use this one, like it says, use message.value and tokens per it to calculate the amount of tokens that we're going to receive. So, UM256, amount to receive is going to be tokens per it. Multiplied by the message.value. Okay, it's giving me a warning that I haven't used this variable yet, but of course we're gonna send this amount of tokens to the person that's calling this buy tokens function. And how do we do this? We're gonna use the instance that we created from the my token or your token, and we're gonna use the transfer method from this already ERC20 contract. We're gonna get your token. Oh, it's already here, I believe. Yes. Your token.transfer. And the transfer is gonna, you can check this one yourself, of course, but the transfer function receives two arguments. If I don't send any arguments, it's gonna complain. Yeah, it says wrong argument count for function call. So 0 arguments given, but expected 2. And we can check the transfer function from the ERC20 Open Sapling contract. It's going to be here, transfer. Yeah, it's going to be here. So the transfer function receives an address, which is going to be the address who I'm going to send these tokens to, and an amount, which is going to be how many tokens I'm going to send to this address. So the amount, we already have it. It's amount to receive. And the 2 is going to be to the person who calls this function. And this is going to be message.sender. Any questions up to this point?
No.
Oh, nice. Okay. We can try to redeploy these contracts and test the interface. Do you have this as well? You. It's very, thank you. Oh, you have this as well? You're doing this? Okay. The challenge does not mention this, but here it's using the name is it's a little weird for me because it says token per ETH, but we're using message.value, and message.value comes in way. And if you already know this, sorry. 1 ETH, it's like one, one, two, three. So 18 zeros, right? And this is way. This is like the smallest amount of ETH that we can divide it into, right? 18 zeros. So message.value, it's not ETH itself. If I send 1 as message.value, it's not 1 ETH, it's 1 way. And I should send this amount of way to be convertible for ETH. But we're going to omit this for now. It's just way too complicated to manage on the interface to input like 1, 0, 0, 0, 0. So we're just going to input 1, and we're going to treat it as if it was 1 ETH. So that we can use this variable that says tokens per ETH. If not, I will have to do some math here. Not that complicated, but still it's kind of weird to manage. Okay, so if you have copied the code, we can just, okay? Wait. We talked about this already, about the events, and here it's suggesting that we use a buy tokens event. We have it already here commented, so we're just gonna uncomment. Remember that you can use Control K, if you're on VS Code, you can use Control K and Control U, and it's gonna uncomment. And for comment, you can use Control K and Control C. Okay, so now that we have this event defined, I can use this one over here and just send the variables that I want to log. So my buyer address is going to be the sender, of course, message.sender, and the amount of ETH that the buyer is sending is message.value. And again, this is just a simplification. We're going to treat way as if it was ETH. And the amount of tokens that the user is going to receive or the buyer is going to receive, it's already calculated here, and it's amount to receive. Nice. Oh, what is this? What is this? Oh, I forgot the emit keyword, of course. So if we remember correctly, yesterday we can see these events thanks to scaffold ETH here reflected in this in the interface here in the events tab. So if we don't have this, we cannot see when we create or buy tokens. But now that we have that we are emitting the event, we are gonna see this here. It's time that I think it's time we redeploy this and try this one out. Oh, it says that we should edit the front end to no, we should edit the script to deploy the vendor again. And this is going to be deploy vendor, and it's going to be here. So let's uncomment just the deploy vendor part of this, which is going to be here up until line 38. We're just going to uncomment this. I think this one should not be uncommented. Okay, yeah. And it's missing a contract, and we're going to also uncomment this one as well. Okay, so as I said, this is using Hardhat to deploy the contracts. So this is a TypeScript file, and because Hardhat uses TypeScript. And here, I will explain this script just bit by bit. Here it's getting the deployer address of the local Hardhat chain. Here it's getting the deploy function from the Hardhat deployments module. And here it's getting the contract, my contract, the token contract. And here is getting the address of the token contract. Now it's calling the deploy function, and this is going to deploy my vendor contract. Here they have it has some arguments that we don't care for now. But the thing that it's interesting here is that when we deploy the vendor contract, you remember that we use in the constructor we use a token address here. So we need to send this token address to in the deploy script, and we're sending it like this. With the arguments variable, we're sending the token address. So now the vendor has access to the token contract and the token methods. Okay, I don't know if there's something else. Yes, we also have a UI here that it's going to allow us to buy the tokens. For now, we just have transfer, but we can uncomment this so that we can buy the tokens from the interface itself. And this one is in token vendor page.tsx. Page.tsx. Token vendor. Here and the buy token section. Tokens per ETH. Oh, we should also uncomment this one. Okay. So now we have the buy tokens functionality here in the interface as well. We can redeploy the contracts to get a fresh start, and you can do this with the yarn deploy. And just to be sure, we're going to reset the deployment to get a clean contract. Okay. So now we have your token, which is the ERC20 token that we created, and we have the vendor contract here as well to debug. We can check that the total supply minted for the token is 1,000, and that I have the 1,000 tokens, of course, with the balance. Oops. It's this one. Yeah. Let's try the buy tokens function from the interface, and I'm going to try to buy 100 tokens. It says execution reverted, so it says transfer amount exceeds balance. And why is that? It's because right now my vendor doesn't have any gold tokens. I'm the only one that owns the tokens, and I have the total supply. I have it in my balance as a user, right? My vendor contract has 0. If I can check this here, I can copy the vendor address, and then I can check that the balance of the. I can copy the vendor contract address, and check that the vendor contract address balance of gold is 0. Okay. So he cannot, the vendor cannot sell me some tokens, and I cannot buy tokens from the vendor. So we're gonna do this now. I think yes. Yeah, we're gonna transfer some of these tokens to the vendor so that it has some supply. It's like filling up the machine with crypto, or filling up the machine in real life with drinks. It says we need to do some changes first to the token contract. We're gonna do this now. Instead of, let's just go to the token. Instead of minting directly to the front-end address, the user that is using the vending machine, we're gonna mint the initial supply of 1,000 gold tokens to the message.sender, which is gonna be the deployer of this contract. In this case, one of the accounts from the local hard chain. And this is gonna allow us to transfer this 1,000 gold tokens to the vending machine. And how we're going to do this, it says here, in the deployment script, we're going to call the transfer method from my token, and we're going to transfer to the vendor address 1,000 gold tokens. Let's do that here in the script. So what's the script doing? The script is getting the contract, the vendor contract address with the get address method, and then it's using the token contract transfer method. And it's going to transfer to the vendor address 1,000 gold. So if we redeploy the contracts now, we should see that the vendor has some gold tokens in his balance. So let's go with yarn, deploy. Okay, now my balance is 0 gold, but I can check the balance for the vendor contract, and it's going to show me that it has some balance already. Yeah, so now the vendor is the one that has the 1,000 gold tokens inside, in its balance. Well, let's continue. I don't know if you have any questions to this point. Yeah.
But
transfer amount exceeds balance. And let me see what you uncommented.
Uncommented. Here. Transfer ownership.
Yeah, this one should be commented still, because we haven't reached that point. Yes. I got that error as well when I was building, so no worries. Now that what it says.
Transfer amount exceeds balance.
Yeah, you haven't changed the token contract. Yeah, you still have a mint function which is sending these tokens to the front-end address, and we need this one to send this to the deployer address, which is message.sender. Oh, you can uncomment that, but this should be message.sender.
You didn't get it. Okay. I wasn't uncommented the page. Message said okay.
Let me know if you need me to stop so you can copy the code, or
okay.
Should be alright.
Cool. Yeah, we're good.
Okay. Nice.
Thanks.
I don't know if this should be recorded as well. It's fine. Okay.
Yo estaba queriendo igualarme a la mala.
Ya, a ver.
A mí me sale este error cuando le hago el reset.
Es que este de aquí todavía no llegamos aquí. Todavía no hay que comentarle este de aquí. ¿Dónde está?
Este también supongo porque hasta aquí no estaba seguro si era lo que dijiste que había que descomentarle, entonces ahí estaba igualándome que llegué estaba.
Pero si ya le tienes, déjame ver el token. Aquí. Ah, ya le tienes, ya le puedes descomentar el otro que le comentaste ahorita. Sí, ahí le puedes dejar.
No es que yo no puedo casi dormir nada. Me la espalda.
¿Por qué? ¿Por la caminata?
No, o sea, yo tengo problemas de la espalda ahorita, peso. Y ya pues, estaba muriendo ahí.
Ahí está, chévere. Bien. So I tried this already. You can try that as well. But now we have our buy tokens function working. I tried to buy 10 tokens right now, and it worked. So I'm gonna try to buy some more. Yeah, let's try to buy 20. It worked as well, and it's lowering down the balance from the vendor contract, of course. And since I already own some gold, I can transfer this gold to another user, let's say my MetaMask wallet, and I can transfer this with the transfer token function, and it's gonna be successful, okay? You can check some events that we did right now in the event tag as well. Or you can not use the interface and directly try from the smart contract debug module. Let me just plug in my laptop. So another nice feature that we get from the scaffold contracts that we have, the interface that it came when we cloned, is that we can now display the vendor ETH balance and the token ETH balance as well. This is already in the page.tsx, and it's gonna be, I'm gonna show you right now. It's gonna be over here. We have already a function to fetch the balances from the vendor and from the user that's using the vending machine. So we can uncomment this on line 35 of the page.tsx token vendor, and we can uncomment this when it says vendor balances. Vendor balances, right? Just delete these ones and it's good to go. Yep. Let's see the change reflected in the interface. Yeah, so now you can see the vendor token balance and my token balance, which is different. You can also see that the vendor already has some ETH. Since we are using the buy tokens function, by transferring some ETH, the vendor receives this ETH and stores it in the contract. In exchange of depositing or transferring the gold tokens to me or the user who is using the vending machine. Nice. We can move on then. We are done with checkpoint 2, I guess. Let me check. Yes, we try this. Yeah, so I already tried all this and it worked. Yes? Okay. So now we're going to add some precautions, I would say, to the smart contract. We're gonna use the ownable contract from OpenZeppelin, which is going to allow us to restrict some methods to the owner of the contract, or transfer the ownership to another user. Transfer the ownership of a contract to another user. So in this case, since we're going to work on the withdraw function right now or later on, we're going to have to use we're going to have to restrict this withdraw function to the owner of the contract, of the vendor contract, so that no one else can withdraw all funds from the vending machine. It's like if we allowed only the maintainer of the vending machine to remove the coins from the inside of the machine and to empty the machine, basically. We should not allow anyone else to do this. So for this, we're going to use the ownable from the OpenZeppelin. Like I said, you have it already here in the vendor contract. You have a commented line here, which is importing the ownable contract from OpenZeppelin. You can check the ownable contract, of course. If control click, you can navigate to the contract for OpenZeppelin, and you can check all the methods that it has and all the modifiers that it uses. But we cannot use the ownable contract if we don't use the is keyword. So we're going to use this is keyword, is ownable. So now we're inheriting all the functionality from this contract, the ownable contract. And this is going to allow us to transfer the ownership of a vendor contract to the deployer of the contract. And we're going to do this in the script. So we're going to navigate to the script, and we're going to uncomment this line here. You can grab your front-end address from the interface over here, copy address, and paste it here. So now the owner of the vendor contract is going to be this one, the front-end address. Yeah, we're going to try to do this now. And since we haven't made any changes to the contracts, we're going to have to use the reset flag to redeploy the contract. Okay. So now we can check who's the owner of the vendor contract, and it should be me, 0x966, etc. Here we have a new variable, owner, and it's showing me that I'm the owner of the vault contract, and I'm the only one who's going to be allowed to withdraw the funds. Okay, you should check this one too if you have it. And let's move on. So now is the time to work on the withdraw function. And this is fairly easy. I'm going to explain it to you as well. And this is why we inherited the ownable from OpenZeppelin. let's go to our vendor contract and let's just create the withdraw function. This is going to be public. And here's the magic of the ownable contract. This is going to allow me to use a modifier that its name is only owner. What's this only owner modifier going to do is just require that the person who sends or who calls the withdraw function is the owner of the vending contract. And if it's not, it's going to revert the execution of the contract. It's going to fail, basically. So this is thanks to inheriting this one. So how do I withdraw all the balance? You can send, as we discussed before, you can use the transfer, you can use the send, or you can use the call method directly. And I'm going to use this one. Yes. This one's not necessary, but you can also check that the contract has some balance. If it doesn't, it will revert the execution, but it's optional, of course. And this is the function that sends all the balance, all the ETH balance from the vending machine to the person who's going to call this withdraw function. And here's where I tell you that you can use also the send method. You can use the send and transfer method as well. Some of these are not recommended, of course. We already discussed about this before, but you have, I'm going to send this link here so that you can check some more on which one is the recommended way of doing this. For now, we're using this one, the call method. But you also have the send and you also have the transfer method. Okay. And if the send is not successful, we're gonna revert the execution with this required. It should be successful, or if not, it's gonna show this error message. So now the withdraw function's ready. We can redeploy the contracts, but I will do this after we finish the checkpoint 3, so that we can check all the functionality. Okay, everything good up to this point? Yes. Okay. This is the last part of the challenge, and this one is going to require us to learn the approved pattern of the ERC20s. So we're going to read this one carefully, and step by step, how does this work? This is going to be for when we want to sell the tokens back to the vending machine. So how do we do this? First, we have to allow, it's kind of weird, but we have to allow the vending machine to get some funds from my wallet or from my balance. And of course, the blockchain or the EVM has this security implemented where this is not possible unless I approve the vending machine to withdraw the balance from my wallet. And we can do this very especially with the approve function. Very simple. So the steps that we're going to take is first, the user of the vending machine, I'm going to call the approve function from the token contract, and I'm going to say that the vending machine or the vending machine address is allowed to withdraw, to spend some of my gold tokens, or to take some of my gold tokens from my balance. And then I'm going to, I'm going to call from the vault contract, I'm going to call the transfer from method that is gonna take the tokens. I'm gonna just do a little diagram here because I'm getting lost.